Good morning, ladies and gentlemen. It's Dr. Jones again. And as I said, we're going to pick up our conversation where we left off last week. As you recall, we were talking about photosynthesis and how photosynthesis is how we make sugar molecules from light energy. So this class, or this episode, we're really going to be talking about, so now that we have sugar, what are we going to do with it? And further go into why photosynthesis is so important. Now, as always, we've got to start with our standards. And as we said, the standard for our middle school actually links up with the standards for our high school. Alright? So again, with our middle school standard, we're looking at how photosynthesis and cellular respiration work together to cycle energy through not only ecosystems, but through organisms. With high school, we focus first on the reactions that are involved in photosynthesis. But then we move next to, okay, now that we have that molecule, that sugar molecule from photosynthesis, how do we use that to keep organisms alive through the process of cellular respiration? And how do we rearrange those molecules to get energy out to allow a cell or an organism to do all those characteristics that we talked about that are unique to living things. So, let's talk about cellular respiration. Now, I'm going to tell you, cellular respiration in itself is kind of a misnomer. Here's why. Most people, when they think of respiration, they think of breathing, right? Well, in terms of science, and especially in terms of cells don't really breathe, they don't have any lungs. So when we talk about respiration in terms of cells, what we're actually talking about is taking oxygen and producing carbon dioxide through oxidation. I know, huh? Think of it this way. Oxygen goes in, carbon dioxide comes out. But in the process, you make energy. That's what respiration is about. So when we go through cellular respiration, notice two things have to occur. Oxygen has to go in, and carbon dioxide has to come out. Now, this is the equation for cellular respiration. One of the things that I want you to notice is that for you to go through cellular respiration, you need more than just oxygen. You also need what? Glucose. You gotta have an energy source, right? And notice, the number of glucose molecules, which again, 6 carbons, equals the number of what? Carbon dioxide molecules. 1 carbon dioxide, but you have 6 of them. Again, conservation of matter, conservation of mass, okay? And so what you find is that in this process, you're going to be converting glucose and oxygen into carbon dioxide and water. And in the process of doing this, breaking these bonds, you're going to release energy. Okay? So, just like with just like with photosynthesis, cellular respiration has the equation and it has the process. Here's what I mean. Remember, with photosynthesis, it was carbon dioxide plus water equals, or giving you with light, oxygen and a glucose molecule. Well, with cellular respiration, you have a glucose molecule plus oxygen giving you carbon dioxide plus water. The difference is, with photosynthesis, light energy went in. With cellular respiration, chemical energy comes out. That's what an ATP is. It's actually a chemical molecule. To be very, very specific, it's one of our nucleic acids, like DNA and RNA. I know. What? Yes. Now, again, just like I told you, step 1, you probably have seen this in elementary school. You definitely saw it in middle school. Once you get to high school, we leave this equation alone. Why? Because this is like just the primer, where we're not even painting yet. We have to get to this side of the house. This side of the house is where all of the action occurs. So this which is the process of cellular respiration, gives us this, which is just the basic reaction. Okay? Now, let's talk about why things are like this. Give you an example. So I started reading The Count of Monte Cristo. You may say, how did you get to The Count of Monte Cristo? All right, so let me take a step back. So Lovecraft Country, if you got HBO, you know what I'm talking about. They mention a book. So I'm like, oh, book. It was done by Dumont, which is a black man. All right, black author, got it. Great. I remember the movie. I'm going to get the book. That's the book. Here's why I'm like, that's the book. If you get the unabridged version of The Count of Monte Cristo, it's 640 pages. That's the abridged. If you get the unabridged, it's 982 pages. The movie is only 2 hours and 15 minutes. And the bad part about it is, there's so much in the book that they couldn't possibly put it in the movie. Same kind of deal. When you learn this equation, it was like the movie. This is what you're responsible for. That's the book. Alright? So, if you're looking at your cellular respiration process, it's actually 3 processes. Okay? Here's what I mean. First, you have this thing called glycolysis. We're going to talk about what that is. Then, you have this one called the Krebs cycle. Not Krebs cycle, Krebs cycle. Yeah. And then lastly, you have the electron transport chain. Alright, so we are going to break down each of these. And we're going to start with glycolysis. Now, again, just like I broke down last week photosynthesis, we're going to break down glycolysis. So first of all, if we look at glyco means sugar. Okay? Okay, cool. No problem. Lysis means to either break down or break apart. So when you look at glycolysis, what you're actually doing is taking a sugar molecule and you're breaking it apart. And to be more specific, you're taking a sugar molecule with 6 carbons and you're breaking it apart to give you 2 sugar molecules with 3 carbons. Think about it like this. Man comes in the store, say, hey, I got a 10. I need 2 5s. Dude behind the counter says, all right, I'll give you these 2 5s. Now, let's be real. That's if the guy is generous. Normally, if you go from making a 10 into 2 5s, the dude behind the counter, like, you got to buy something. I mean, you know, candy bar or something. So he really going to just give you like 1 5 and 4 1s. Because, you know, making change ain't free. Neither is this. But we'll get into that in a second. But my point is, what you're doing is taking the molecule and making change. Alright? Again, same number of carbons on both sides, same number of hydrogens. You know, pretty much, more or less. Alright. Because remember, we got some things that pop out. Now, let's talk about why glycolysis is important. Fun fact. Alright, so this is a OMI, or a OM. I think that's how you pronounce it, OM. I think so. Anyway, here's the thing you need to know about this guy. So this little blind, flesh-colored newt, aka like a aquatic gecko, it can go 10 years without eating. It doesn't eat very much food. However, if we look at an elephant, from Hilda over here, she eats anywhere from 100 to 400 pounds of food per day. Here's what I'm saying. If you look at glycolysis, remember, you're not getting much out of this. 2 ATPs. Certain organisms, that's all they need. Other organisms need a lot more. So, when we look at, well, who needs what? Here's what I want you to understand. We have 2 main types of organisms, alright? Get real broad here, so follow me. We have our prokaryotes, and we have our eukaryotes. Prokaryotes, bacteria. Archaebacteria, that's old bacteria. Not like, no, not old bacteria as in old in age. Old bacteria as in ancient, prehistoric. So think of these as bacteria that you would find like in hot springs or places that are very, very cold. Namely, outside of another organism. Because think, human beings, we have bacteria inside of us, but those bacteria are used to our temperature. Dogs, cats, rats, bats, all of them have bacteria that are associated with them. Those are these eubacteria. You thinking about new. Well, one reason why they're new is because they are in constant contact with the rest of these guys. These, they were around when it was just them. Alright? You know, it's like those old people that purchased a home when it was just them, no one else. And now all the young folks moved in with the kids and the dogs and the old people sitting on the front of the yard talking about, be quiet. Yeah, that's what we're talking about. Alright, so, anyway. Prokaryotes. Eukaryotes, everybody else. So, we have Protista. So, think about Protists, or like the amoebas and things like that. Fungi is a fun guy. Alright. Plantia, plants. Animalia, animals. So, if you are a protist, a fungus, a plant, or an animal, you are a eukaryote. If you're a bacteria, you're a prokaryote. And if you're a virus, you're not alive. Viruses are not alive. Don't forget that. Alright. Now, big take-home message. What is the difference between a prokaryote and a eukaryote? Well, I'm going to break it down real easy. These guys have organelles. These guys don't. It's like Mounds and Almond Joy. Sometimes you feel like a nut, sometimes you don't. If you look at eukaryotes, you find that you have what? Mitochondria, chloroplasts, you have the nucleus, you have Golgi complex, endoplasmic reticulum. You look at a bacteria, it's meager accommodations. Meager accommodations. You have a cell wall, great, wonderful. They just threw your DNA in this thing called a nucleoid. So it would be like somebody just throwing you a mattress and saying, okay, there you go. There's your bedroom. It's a mattress. Nah, it's a bedroom. It's a mattress. And then, you know, you threw some ribosomes around. That's like somebody just throwing your meals around, not giving you a place to put them. Just like, you know, here's a wine fridge. Here's like, you know, something to put your cans in, but that's about it. Okay? So, understand that the difference between these two, this is compartmentalized, this isn't. Another way of looking at this would be if we said this, which is your mitochondria, organelle. This, cytoplasm, no organelle. So when we look at how this relates to this, prokaryotes do what? This. Eukaryotes can do what? All of this. That's the big take-home message. Alright? Now, in looking at the whole, well, why is one better than the other? Now we got to get to the dollars and cents. Alright? We got to see, okay, what are we doing here? Here's what I mean. Grandpa, I told you before, said you need money to make money. True. So if you look at glycolysis, 2 ATPs, real cheap. That's, I give you I give you a 10, you give me 2 5s. But now, if I give you 100, I gotta take some. I'm not about to just give you like 5 20s. Come on, man, you can throw me out with like $10 or something. So if you're looking at this, here's what we're saying. For those prokaryotes, those simple organisms, 2 ATPs, perfect. They're happy. They're fine. But for eukaryotes, nah, we got bills to pay. We need some energy. And that's where we get these other 36. Now, I know. Some of you guys are thinking, wait a minute. I thought 2, 36, that's 38. I told you it takes money to make money. So this whole process is going to cost you 2 ATPs. But you got them. Just like the dude with the 100. You got $100. I'm just asking you for like 10 just to make change. Man, gotta keep the lights on and everything. You know what I'm saying? So, here's my take-home message for you this week. understand that when we go through this process of cellular respiration, what we're actually doing is taking all of those carbohydrates that we get from plants and we're using them to make energy so that we can continue to survive. I hope that this explains why sugars are so important, and I hope that you have a great day. I'll see you next week.